Hello, everyone, and welcome to Algebra 2, Section 5.3, which is on graphing radical functions. So I have to tell you, if you were in school, I would be teaching very little today. Instead, I'd be making you work it through, figure it out with your groups. So this first section says, match each function with its graph and explain your reasoning. Then identify the domain and range of each function. So if I were you, I'd pause the video and see if you can figure that out on your own. But of course, I will do it for you. So the first one is a square root function. And whenever you aren't familiar with a new function, you can always make a table. I usually start with 0. The square root of 0 is 0. The square root of 1 is 1. I'm not going to put in a 2 because I don't know the square root of 2, so that's not very valuable to me. So I think to myself, what's the next square root that I know? Which is 4, and the square root of 4 is 2. And to really make a table valuable, you usually want to continue on to some negative numbers. So the square root of -1, oh, there is no square root of a negative number. Okay, -2 doesn't have a square, no negative number. So that's very defining for me. Now I know that I'm either looking at this graph or this graph because I'm trying to figure out, because I'm looking for a graph that doesn't have any negative x values. So what else would not have any negative x values? A fourth root. So same exact thing. And that is, you're not going to take the fourth root of a negative number. So that's part of the way that you can know. So let's see if we can figure out which one is which here. So I'm going to start again. The square root of 0, not square root, the fourth root of 0 is 0. The fourth root of 1 is 1. But on the next one, I jumped to 4, but I don't know the fourth root of 4. So I have to think, what's the next fourth root that I know? It's not until 16. 2 to the fourth is equal to 16. So the fourth root of 16 is 2. So how does that make these two graphs different? Well, partly you could just check points, 0, 0, 1, 1, 4, 2. So this must be the square root of x, which by default makes this one the fourth root. But see how even at 10, it hadn't reached 2 yet. It's not going to reach 2 until it gets out here to 16. So what I want you to see is that this graph is much flatter. The fourth root is going to be a much flatter graph than the square root. So now I have the last two to do. And I have a cube root and a fifth root. So without doing it the same way, this time I'm going to think to myself, well, they both start at 0, 0. They both can have negative and positives. They both go through 1, -1. But then this one is flatter. So which one do you think it is? So think about it this way. A cube root, the cube root of 8 is 2. But if you wanted to get a 2 for this one, you'd need 2 to the 5th, which is 32. So again, just like before, the fifth root one is going to be much flatter. So at 10, you're not even close to 2, but here's 8, 2. So this one is going to be your cube root, and this one is going to be your fifth root. That's how you can be thinking about it. Now we're going to match the transformation of the square root of x with its graph. So when you're thinking about the square root of x, you know I'm really into having you guys memorize certain points so you can make it quickly every time. So the ones you should memorize for square root are 0, 0, 1, 1, 4, 2. That's the square root graph. And if you think about it, that's what we saw right here, square root graph. So what does it, what do you think that it's going to do if there's a +2 with the square root? If you're not sure, you could plug a point in and actually check it. So you might say to yourself, well, if I put a 2 in, then I'll have the square root of 4, which is 2. So I'm looking for a graph that looks like it goes through 2, 2. Not this one, not this one, not this one. So it has to be this graph. So A is going to go with A. But is there any other thing that you can deduce from this? Well, this graph is our basic square root graph that has been moved to the left. Just like when we learned about quadratic functions, if you had a plus 2 as part of the main function, that moved it to the left. And then if you had something on the outside, this would move it up. So do I see one that has anything on the outside? I do. Letter C has it going down too, but otherwise it's the same graph as A. So I'm going to look for A, something that's been moved over to the left, but also down too. So I believe this one is C. And if it is C, it looks like when it's 2, I get 0. So I could check that point real quick. If y is really equal to x plus 2, then minus 2. When I put in a 2 in, I get the square root of 4, which is 2. 2 minus 2 is 0. So I feel very confident now that I've done it correctly. So what do you think about these last two? What do you think is going to move my graph to the right? The minus 2. And what do I think is going to move the graph to the left and flip it upside down? There's my flip, that negative out in front, and there's my moving to the left. So what did we learn from this? We learned that all the things that we've learned so far this year still apply, and they're going to apply to the next kind of graph we learned and the next kind of graph we learn after that, that whenever you have a negative A, that's going to flip the graph upside down. Your H is going to move the graph left or right, and your K is going to move the graph up or down. In other words, the same exact problems or systems apply. So how are you going to make your graph? I really don't recommend that you plot points. I think you should just make the table for the parent graph. That was a little sloppy there. Just make the table for the parent graph, and then multiply the y value by A, shift to the origin, and then plot the points in your table using the new origin. Because this is so similar to things that we've done before, I would love to see you do these on your own. If I were in school, I would not be helping you. I would be letting you work with your group and figuring it out. But of course, you're not in school, so I am going to help you. So on this one, I see it's a basic square root function. So I think to myself, 0, 0, 1, 1, 4, 2. But I am going to shift it. The A is just 1, so I don't have to multiply by anything. But I am going to shift it to the left 1 and down 3. Left 1, down 3. This is my new origin. And so I'm going to pretend that that's 0, 0. So 0, 0, 1, 1, 4, 2. And in this context, you have a choice whether or not you find the next one. Some people are good at drawing a graph and they don't need to, and other people really get off very easily. But I am going to check to make sure your graph is still correct. So the next point, if you needed one more, would be 9. Remember, we're doing y is equal to the square root of x. So 9, 3. So from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. Oh, that was good. Okay, so mine's pretty much right on, but I've also drawn a lot of graphs. So you might consider doing 9, 3 if you have room. If this had been shifted to the right, you probably wouldn't have been able to fit that point anyway. Another square root graph. So my basic points are 0, 0, 1, 1, 4, 2, and if you can fit it, 9, 3. But I'm going to multiply all these numbers by negative 2. So when you multiply 0 by negative 2, it's still 0. 1 times negative 2 is negative 2. 2 times negative 2 is negative 4. And 3 times negative 2 is negative 6. Now I'm going to make my new origin. I'm going to go to the right 2 and up 1. Right 2, up 1. There's my new origin. And here's the points that I'm going to plot. So I have 0, 0. That's right on my new origin. 1, negative 2, 4, 2, 3, 4, down 4, 1, 2, 3, 4, and 9 I can't reach. So this is going to be, ooh, that wasn't very good. So this is all I'm going to do. Okay. So I know some people question this method. Some people are like, why can't I just make a table for this graph? Well, you can, but especially with square roots, you're going to have to keep thinking of numbers that when you subtract 2, it's a perfect square. Otherwise, you're going to get square roots in there, which are going to be no good. So for example, if you pick a number like 3, you'll be good. If x is 3, you'll have the square root of 1. 1 times negative 2 is negative 2 plus 1 is negative 1, which we got, 3, negative 1. But if you picked a number like 4, 4 minus 2 is the square root of 2. You don't want to try and graph that. So my recommendation is that you move the entire origin and pick nice, easy numbers, the same numbers every time, 0, 0, 1, 1, 4, 2. That's my recommendation. All right, now we're going to do some cube root graphs. So the points I'd like you to memorize for the cube root are 0, 0, 1, 1, starts out the same, and then 8, 2. So the next one would be 27, 3, which is really never going to appear on your graph, so I wouldn't bother to know that one. But here's the important part. You can take the cube root of a negative number. The cube root of negative 1 is negative 1. Because remember what a cube root means. It means what root can be multiplied by itself 3 times to make that number. So the cube root of negative 1 is negative 1, and the cube root of negative 8 is negative 2. So you have a few more numbers to memorize, but they're really just the opposites. So on this one, I'm going to move to the right 4 and up 2. 1, 2, 3, 4, up 2. That is going to be my new origin. If you want, you can put a little mark there to make sure you see it. And then my points are 0, 0, 1, 1. Okay, I can't reach 8, 2. But what's really important is that you had better not go above 2 because we know it doesn't reach too high until way out here. So make sure you kind of go below it, okay? And then negative 1, and I can do the 8, negative 2. So 1, 2, 3, 4, 5, 6, 7, 8, down 2. So now when I go to draw it, of course, I want to come along here, get through that. So this does have a very steep little incline there. Try and draw that. But as long as you get the basic shape, I'll be okay with it for right now. The next one is going to move left 2 and down 1. Left 2, down 1. That's going to be my new origin. I'm going to make my table with the points that I know and love. 0, 0, 1, 1, 8, 2, negative 1, and negative 8, negative 2. I should see this on everybody's paper. And then because there's a 3 out front, I'm going to multiply them all by 3. And those are the points I'm going to plot. So 0, 0, 1, 3, 8, 1, 2, 3, 4, 5, 6, 7, 8, and then 6, 1, 2, 3, 4, 5, 6. And then negative 1, negative 3, and then negative 8, negative 6. So this is going to come in like this. It's going to be very steep right there in the center portion. And that's what your graph is going to look like. All right, if you still haven't stopped this video, I highly recommend that you stop it and try and do these on your own. But of course, I'm going to do them for you. So this is a square root graph. So my square root numbers are going to be 0, 0, 1, 1, 4, 2. Remember, square roots don't have both sides like the cube root ones do. So this is going to be cube root, and this is going to be square root. It is being multiplied by 3, so times 3. And it is going to shift to the left 4 and down 5. Left 4 and down 5. From there, I'm going to graph my new points. 0, 0, 1, 3. Sorry, 1, 3, and 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And I don't know. I feel like on this one, I've moved so far to the left, I might be able to fit one more. So 9, 3. And if I multiply that one by 3, it's 9, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And sometimes that just helps you get a better shape. If you're doing homework, maybe not. If you're doing a quiz, you might want to think about doing that. Okay, next one is a cube root. Remember that for cube root, my points are 0, 0, 1, 1, 8, 2, negative 1, negative 1, and negative 8, negative 2. But I'm going to be multiplying by the negative 2, 0, negative 2, negative 4, 2, 4. And I'm going to be shifting to the right 3 and up 2. So from there, sometimes it's better to actually make a little cross than just a point since you're about to make points, unless you change the color. 0, 0, 1, negative 2, 8, I can't quite fit, but it would be all the way down at negative 4. So it would be there. So make sure you don't get to negative 4 before that point. And then negative 1, 2, and negative 8. 1, 2, 3, 4, 5, 6, 7, 8, and 4. 1, 2, 3, 4. So I'm going to go ahead and draw that. Maybe start over here at this point. Go up and like that. Okay, let's do the next one. There's still a few more here. If you have not stopped this video, please stop and try one of these on your own. This one's a little more annoying because it has that 2/5 there. But remember, we're going to use good points. 0, 0, 1, 1. It's just a square root, so I go to 4, 2. And I guess I could try 9, 3. I don't know if it'll make a difference. And then I'm going to multiply by negative 2/5. So that's luckily still 0. That's negative 2/5. That's going to be negative 4/5. Remember, a whole number times a fraction. Make the whole number into a fraction and do numerator times numerator and denominator times denominator. And that would make this one negative 6/5. It's also going to go to the right 3 and down 2. That's my new origin. And then I'm going to plot my points. 0, 0, 1, negative 2/5. 4, 1, 2, 3, 4. Negative 4/5. Don't get to the 1. And then finally, 9 out. I would finally, way out here, be more than 1. Negative 1 1/5. So in other words, you really need to make that shallow. Maybe even more shallow than I did. That's what it would look like. This next one, remember from our lesson the other day, means the same as cube root. So this is the cube root, and it has been moved to the left 2/3. So I'm going to make my cube root points. 0, 0, 1, 1, 8, 2, negative 1, negative 1, negative 8, negative 2. I'm definitely glad I did not plug in the 2/3 first as I plotted my points, because now all I have to do is just start to the left 2/3 right there, and from there I can do my 0, 0, Now 1's a little tricky. I got to go 1 over from 2/3, so it's going to be there. Very tricky to draw. And then 8, 2, so 1, 2, 3, 4, 5, 6, 7, 8, and it's just going to be over a little bit, 2. -1, -1, so I go down 1, and then when I go over 1, remember I'm just shy of it because this is at 2/3. And 8, 2, so that'll put me here and -2. So something like that. So these last two look different, right? So what I want you to do, just in general over the next several years in math, is not panic when you get something you don't know. If you're being asked to make a graph, start by making a table. So you think to yourself, well, when x is 0, then I get y squared is equal to -1. That's no good. When I take the square root of the -1, I get I. So clearly, it's never going to be 0. But more importantly, do you see what just happened when we tried to solve that? We got the square root. Let's rewrite this as plus or minus the square root of x minus 1. Now you know why it's in this section. So I'm going to do both the positive and the negative square root of x minus 1. So I can just use 0, 0, 1, 1, 4, 2, 9, 3. But I'm going to move my graph to the right 1. So I move it to the right 1, and that's my new origin, 0, 0, 1, 1, 4, 2, 9, 3. And I have myself a graph. But then if I do the -1, then that'll change all of these to negative, which would be 1, -1, 4, -2, and 9, -3. Do you see what I got? I got a sideways parabola. So this is not a function, so your calculator won't graph it for you. Your calculator always needs to graph y is equal to. So if this was yours and you wanted to make the graph on your calculator, you could do it this way. And then y2 would be negative. That's how people get around graphing things that are not functions. They break it into two things that are functions, and then have your calculator graph it individually. So one more like that. What do you think? Can you make a prediction? What will happen if you square the x and square the y? So what this does is really unique, and instead of showing you the long way around it, I'll just go ahead and tell you that this makes a circle, which is kind of like a sideways parabola, and then the other sideways parabola, which I realize is a little bit more elliptical. But when you put them together, it does make a perfect circle. And this is going to be your radius squared. So my radius is 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. A little bit hard to draw a really nice circle. Just do the best you can. There we go. So just expanding on our square roots a little bit. Find the domain and range of each function without graphing. So I know that the directions are going to say that, but not me. I always make a super quick sketch. I think to myself, oh, this is a square root function, so I know its basic shape, and I know that it's been moved to the right 13. Why do I do that? Because for me, that's the easiest way to do it. And then I can see that the domain is clearly x is greater than 13 and equal to, right? It's been moved 13 out. And the range is y is greater than or equal to 0. I'm a very visual person, so for me that makes a lot of sense. So how would you do it without graphing? I guess you would just think it through in your head and say, well, I know that we want x minus 13 to be greater than or equal to 0 because you can't put a negative number underneath the radical, so x must be greater than or equal to 13. If that makes more sense to you, then you may do that. But for me, I love to just make a sketch. I sketch. So I think to myself, this has been moved to the right 3, down 7, and it's going like that because it's a square root function, but it's negative. So now I can see, remember this is 3, -3, -7. I mean positive 3, -7. So in my domain, it's nothing before 3. X is definitely greater than or equal to 3. And in my range, y is definitely less than -7. So for me, making the sketch is actually everything. Can you figure it out without? Sure. Again, the domain, you can't have a negative under the radical, so x minus 3 has to be greater than 0. That will always work. And then you can just figure out its shift. But in essence, what you're doing is thinking about it. You're thinking about the graph. At least I am. Last one is a cube root. So this one doesn't matter. Cube roots are always, domain is all real numbers and range is all real numbers. It doesn't matter if it's gone left, right, up, down, if it's been moved backwards, it doesn't matter. It covers the whole x-axis. And even though it looks like it flattens out, it forever keeps going slightly up. So it does have all real numbers as its range as well. All right, you're going to try and do this backwards. I cannot recommend highly enough that you try to do this on your own, but of course I will do it for you. First of all, this is a square root. This is a square root. This is a cube root. And this is a square root. This one is your basic square root. I can see the 0, 0, 1, 1, and the 4, 2. So I know that it doesn't have a number in front. And it's been moved to the left 2 and up 1. If you're still watching, you should stop and try and do this on your own. So this next one is cube root. It goes through 0, 0, 1, 1. So I know that the A hasn't changed at all, but it has been shifted over 2. So x minus 2, because it's gone 2 to the right, and down 3. So these last two are much harder because they've been flipped. You may remember that a flip down is going to produce the negative here, where a flip backwards is going to produce the negative there. I will warn you that lots of people get these wrong. So always check a point. If you check a point, then you can be sure that you did it right before you turn a quiz in. So this one looks like it's been moved to the right 3 and then up 1. And I put the negative in there because I can see that it's going down, but it's still 0, 0, 1, 1. So there's not like a negative 2 there or something. But I just check a point. I think, well, if I'm right, then this equation should work for 4, 0. So I check it. When I put in a 4, the square root of 4 minus 3 is 1. The square root of 1 is 1. Minus 1 plus 1, 0. And I feel really good about my answer. On this one, same thing. There's no A in any of these. So 0, 0, 1, we'll do that before the end of the chapter. 1, 1, 4, 2. So it doesn't have a different A, but it's been moved 1, 2, 3, 4, x plus 4, and then down 1. But what did I say you should always do? You should always check a point. Oops, minus 4. Duh. Because it's been moved to the right 4. So I still check a point. If this is right, then the point 0, 1 should work. Pick an easy one, right? Here's the point 0, 1. So I plug in a 0. Ooh, I'm already in trouble. I plug in a 0, and I get the square root of negative 4, which is undefined. So I must have made a mistake somewhere. And this is the one that everybody gets wrong. So this negative actually affects the entire thing. So whatever's in here That's what it affects. So there is an x minus 4. This was the correct thing. We do want to move it back, but that negative affects the entire inside. So then you'd have to distribute the negative if you wanted to write it without the parentheses. And it actually does end up being plus 4. I had it right, but for the wrong reasons in the beginning. So now I check it. So I put a 0 in. I get the square root of 4. The square root of 4 is 2, and 2 minus 1 is 1. So now I can feel good about my answer. So watch out for that negative. It affects everything on the inside. All right, you did it. You made it all the way through this lesson, and I hope you have a great day.